is telling us about something, then that is an information. So fetching information from data is going to be crucial task. Um, uh, and this information is, if you can see, that this is the result of processing by which we extract some conclusion that can be used in various ways. Uh, and this is what the, from the raw data, if we are able to process some of the information, that is what we know as data analysis. And a particularly topic of this this program is multivariate data analysis. Here only the thing is that we are having several variables to take care of, that we think that variables are. So we think that, yeah, these variables may give us a good explanation about the behavior of system that we want to you know um, know, or we want to uh, you know um, we want to think about, or we want to know about the system's behavior. So so what is the purpose of data analysis? It is to I have said this, that is extracting information that is not easily deducible. Oh, now I should not be putting disqualified. That is not easily deducible. Why? Because this is a qualifying statement. I mean, something you may feel that it is easy, and I mean, uh, just the role is, or the purpose is to extract information from data. And there are lots of huge amount of data. Maybe sometimes you are having too less data as well, because if you are doing collecting some primary data specific for some purposes, you may be having very very less data as well. So which leads to the possibility of carrying out studies on the mechanisms of the systems that have produced them, which allows us to develop a model to forecast possible response of these systems and their evolution in time. uh, and that is what the real purpose of in doing any analysis. If you can see the process, maybe it starts with if the way as a researcher we are seeing, way if we are seeing as an even in consultant, if we are seeing, first thing is that is very very important, is defining the problem. That means we want to know first that what is that we actually are looking for. So that if we can define the problem, then it becomes easy to do further analysis. Because once we are defining the problem, then we can think of from where we will get the information. So the sources, so those data sources from where the information can be retrieved, that we will search on. We will so searching that data, then extracting that data, and then this preparation is something like, because you are having lots of sources sometimes for a particular problem, then you have to come up with a structured way to arrange those data. And that is what the data preparation is. There are so many things that may be missing values, repeated values, some outliers, something that you cannot validate. I mean, there are several things that go into this data preparation thing. Um, so basically, this is about the data extraction and data preparation combined. Uh, Several times you iterate, in the sense that you may fetch some data, you do some structuring of that, then you think that this is not enough. You go with another source, you fetch some more data and prepare again to one format, so as to you can analyze. So so this is iterative thing, nothing like an algorithm that no, first we will search for data, then I will extract, and then subsequent preparation. So it will go in the loop. Anyway, But then once you are having some data, how to know that this data is sufficient, or whether that there is some meaning in this data, how to proceed further. That there you need to visualize things. So something that you have to process in getting the meaning out of that data. And now um, sometimes uh, the limitations that we are having, our human brain, that we cannot interpret lots of data just by seeing, looking at the numbers. So but the beautiful thing, how we have evolved, and how we have become capable of decision making, is that we have a good visual memory and visual processing thing. That is the essence of human brain. And that's why you will see that once you are going to a theater and you're watching a movie which is based on a novel, you get through it quickly rather than going through novel. So you can see that the visual thing that appeals a human brain. I mean, there is no other medium that can parallel to that. And that's why so if you want to know the meaning, if you want to know more information, or you want to look into the information hiding behind data, you need to visualize. And this has become a separate field. This specialized field, data visualization. A very interesting field it is. And how you can visualize when the dimensions are too many. And for example, I'm working in the field of quantitative finance, and I'm thinking about visualizing limit order books for shape. So that has a very interesting component. There are three, four dimension in which we want to see, but the problem is that visually the limited capability we are having, that we can understand mostly three-dimensional thing, and then we can make it four-dimension by putting as a movie or as an animation. But then we need to visualize more dimension and how to do that. And those are interesting problem to do. Um, there are several methods to do that, and you will learn in this program some of the methods. Uh, those are very interesting. So graphical representation, or say visualization, or say looking into the data, as you can see, is a very important part, very important part for anyone who is doing research, either as a practitioner, either as an academician. You have to visualize, and whoever is having good vision will get information much quickly, and that actually leads to this model formulation. Why do you need model? Now, not to catwalk, but actually, model gives you a way to explain information much better way, where you become independent of actually data. And that getting rid of this data is very important thing if you want to use this information for prediction, or even thinking about evolution of some behavior of any system. And their model helps you, because it gives you tractability, it gives you predictability, it gives you that confidence that you can think of taking any decision with respect to the system that you are analyzing. So but people say that there is a very famous quote that all models are wrong. Some are useful. and and that you would have seen in this COVID time, that several people came up with different model of saying that when when we will overcome this this wave of coronavirus infection. uh, you know when we will able to control, and everybody, each of them were failed, in her attempt, or uh, so it's a very very difficult task to come up with a good model. And so model validation, that gives you some confidence about your model, is very very important thing. But in this today's talk, that I will be having this interaction with you, I will not touch everything. I will be mostly in this data preparation maybe, and data visualization maybe a little bit. That is what I'll be more focused on. Why so? Because uh, I cannot do justice with all of these things. These are very very interesting, but uh, it requires more time to learn all those things. So what is that I will be doing? I will explain in a few minutes. But before that, uh, it's so important point about this data preparation, data visualization before, and getting into the model, is this about this, how you are choosing your data. Yeah, definitely. You need to put some amount of way on choosing your data, how you are selecting, and that actually depends on how much you are in the problem. I mean, uh, how can you how you are seeing your problem, what how much clarity you are having about the problem, and then you will see that what are the dependencies this problem is having, and from where you can get those dependencies sorted out. So you will go and retrieve, you will search, you will request for those vital information. But information, um, I mean, is crucial, that will be lying somewhere. uh, if everybody is can process that, then why somebody will approach you to do that? So that is why you will be paid, and that's why you have to put lots of energy into this data selection thing. Poor choice of data may lead to very inferior model, and that will not help you anyway. So as I was saying, that mostly I will be into this data extraction, data preparation, and that is an important thing to do, because and after that data visualization, because I mean, if this is done, then you can think of putting some analysis, or some model you can think of building or formulating those models. So you know that these days, maybe somewhere you will be having some structured data available as well, and that variables that you can identify. Maybe you can think of putting that in a tabular form. You can fetch the information by putting some query, but several times you will be having different formats to deal with. We call this as big data. That there is nothing big about that. It's not about the volume, but it's about it's about the variety, you can say, or complexity, you can say. That's why we're calling this big. And data preparation is nothing but you are fetching that, you are cleaning that, normalizing, transforming, and then you are putting in tabular form. And uh, this is, I mean, this looks very easy, but actually you are doing lots of time in 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 cleaning and normalizing and transforming data. And I have some experience of doing that. Mostly, you can say that 50 to 60% time you are in data actually. Then you can think of putting up any model. So what are the potential problems? Yeah, some of the data will be very, very invalid. I mean, that is not going to be useful for you, ambiguous. I mean, you cannot make any sense of that. there will be missing values, and how to deal with those missing values. That you have to take a decision about. For example, I work in option pricing domain, and you know that not for all the strike prices the options are traded. Now, if you want to know at that strike price what is the fair price, you don't have, or what is the market price maybe, you don't have any information or data available there. Or maybe if there is a data, that data is a bit old in a sense when you are looking as an option trader. And now, whether you are going to delete that information or that data, or you are going to use that, I mean, that's your choice, but you have to think about why you are doing that. That's uh, that is an important thing to think about. And there will be several problems, otherwise problems also. For example, out of the range data, maybe several outliers, noises in the data. Some of the fields will be replicated, so you have to do lots of cleaning. You have to think about that, and there is no one way of doing that. It all depends upon from which source you are getting data, how much reliable that data is, and how that has been organized. Right. So it will take some effort of uh, preparing the data for market. So the next part is this data exploration that I was telling you about, that displaying and exploring to all this is about understanding the information in the data. You will put some charts, you will put some you know some way to visualize that, maybe scatter plot, maybe for example, in stock markets, people use this Japanese, candlestick, and then they put lots of, this support thing, line, trend lines, moving averages, and so on. I mean, why they are doing this? They want to get sense of, what the data is telling. So visual sense gives, more information to us to proceed, and that's why visualization becomes very, very important, because this all going to lead to come up with a good model to predict the system. uh, if I mean, within some range of accuracy, maybe that will be acceptable to us. uh, this model I was telling about is the mathematical model. The translation, this is a translation of information into mathematical form. This is nothing but using a language of mathematics to explain the behavior of system, and that is what the mathematical model is. So people always get frightened, with this mathematics, uh, in usually during our early days. But mathematics actually is a language, and language which is built on logic. And in this world, everything is flexible, everything is deducible, everything you can question, and that's the beauty of this language. And that's why we write everything in a mathematical form. And because then we can track, we can predict, we can think, we can analyze the behavior of the system uh, in a logical way. Right. And this mathematical form describes system responses, which can make predictions about the system response to certain inputs, and that is what we are interested in. So, oh, so three fields mostly. You definitely you have to know about the the field from where that problem is originating, but mostly you need three of the very important uh, discipline to go with any analysis on data. One is about this computing, where you need to know. Even if you don't want to go too deep into these things, I have listed a few things. For example, maybe how you are going to get those data, in which form, which file type, how you will visualize, or how you will open that file types, how you will access that. I mean, that information is important for you. And then if that you are using something, you want to take some information, then web scraping these days, you are having some tools that can do web scraping as well. Sometimes you have to code, to process your data, as well as to come up with your model. So there are some very good programming languages. A few of them that you would like to know. And then there are some proprietary software, you all know, MATLAB, Apple, then um, that can be used to do lots of computing. But we will be interested mostly in Python, and I will tell you why Python in maybe a few minutes. A little bit of mathematics that you require, and that is, linear algebra. Without that, sometimes it is very difficult to comprehend. So that is the most useful thing that you would like to go through it. And then numerical analysis, maybe because we are dealing with computers, and that's why you need to know a little bit about how computer thinks, or how computer stores this information or data, what are the limitations, and how it evaluates. So numerical analysis, numerical computing, or scientific computing, whatever you can call, is also required. Not too much. Not I'm saying going into the PD models and other things, but yes, a little bit of, maybe I should say, numerical linear algebra. And then optimization, definitely, because most of the models will require to do some sort of optimization. Uh, Statistics, definitely, there are several things: Bayesian methods, regression, clustering. There's several statistical techniques that can be used, PCAs, that you these things that definitely you are going to get some glimpse of that in this course, I'm sure. So uh, why Python? And that is why I was telling you that I will be mostly interested in Python today. And why Python? So there are several of the important feature of Python. First, I will say that this is freely available. But everything free is not good, right? Uh, but not only about this freely available thing, there are a large number of libraries that provide a complete set of tools uh, for analysis and data manipulation, and very powerful language. Um, uh, Another is this ability to interface with other programming language. So you, if some of the packages are there in Fortran, but these are very tested packages. So it can interact with Fortran code. It can interact with C code, and it's easy. It's not difficult, and that's why Python is a very important programming language to know. Many other applications. You are having so many packages, well developed packages that can handle those applications. So these are the features. But if you will ask a little bit deep into why actually Python, so I will say that there are so many of features. It is an interpreted programming language. You write a code, you need an interpreter to execute it, and And the interesting part is that I mean the interpreter is, for every operating system you are having an interpreter, and you don't need to change your code now for that was happening, in several of the programming language. So Python is uh, uh, here it is very stable, in the sense that once you have written a code, then you can say that on any operating system you will be able to run the code. There is no compile time. You will see today that just you are going to put the command, and then you will see the result, and that's another interesting feature. Pseudo compiled, highly portable, and portability is about this executing in on any operating system. Object-oriented programming language, here there are uh, you know uh, several important property of having a language, an object-oriented programming language, because then you can come up with a program and that is separated with data, and then you are just quickly input the data, and then you are getting the result. So that the specific properties, polymorphism, data encapsulation, inheritance, those are the things that you see in object-oriented programming. So Python is that. It allows us to specify classes of objects and implement their inheritance. But unlike C++ and Java, there are no constructors and destructors. This is the difference between Java and Python. Python also allows us to implement specific constructs in our code to manage exceptions. So exceptions handling is also there in Python. This is an interactive programming language. We can write code made of a lot of lines similar to C++ or Java, and then launch the program. This is one way. We can enter the command line at once and execute it immediately, getting the results of the command. So in for example, I will show you in a Spider. A Spider is an IDE of Python, and there I can put lots of series of commands to make a whole program out of it, and then I will execute that particular program. This is one way. But other way is that that you will also see on the when I will show you in the Jupyter notebook, that each of the line I can execute it, and then again I will go further. So I mean this lots of interaction happen, and it's just something like if you have some exposure of MATLAB, that MATLAB idea is here as well, and that's an interesting feature of Python, and that's why Python is getting more popular these days. Python is a programming language that can be interfaced, and that I was talking about, that it can do this dialogue with another programming language, and that is what it is saying. It can be interfaced with code written in other programming languages such as C, C++, and Fortran. It's an open source programming language, and that's why it's freely available. Every module or library in the network is open source, and that code is available online. And there is a non-profit Python Software Foundation, which was created in 2001 and has given itself task of promoting, protecting, and advancing the Python programming language. So you need not to worry about that, whether everything will get corrupted, because they are doing their job, and this is free of cost. They are offering it. So that's why scientific community these days, or even in industry application, I know that programming language Python is preferred. Yeah, and this is what about the Python is a simple language to. You will see this today. I'm sure that you will see that how simple language it is, and it is very easy to learn, very easy to use. But this doesn't mean that it is shallow, it is narrow. No, you can do lots of high level computing using this language. And that's why you can see that these days if you will do machine learning, I mean, um, you will mostly see the Python codes there. Okay, so heavy computing, you will see Python involved. Yeah, uh, there are limitations. One limitation is that it's slower than C maybe, right? But then there are some applications which actually translate your code into C. So Python, C Python maybe you can say, is that language that people can translate and that overcome this problem of Python. So everything, once you are in a production phase, you can translate into that and then put up an application that will be much faster. So so how to start with this? So there are several ways, but you can install Python in your computer and then select one of the ID. There are several ID available. Some are free, some are not. What I will suggest to start with that, there are distributions available in that make this installation of Python, the libraries, associated application. You can everything in a one package. So that I will strongly recommend to use that. One of the distribution that I am using is known as Anaconda. So it's a free distribution of Python packages distributed by Continuum Analytics. This distribution supports Linux, Windows, and Mac OS operating system. It comes bundled with most of the tools to set up a Python development environment. The basic distribution includes Spider as the IDE, IPython Qt console, and Jupyter Notebook. So that is what I will recommend. Just to go to this website www.anaconda.com. You will not fall into Amazon forest. you will go to a web link, and then from there you can download Anaconda. Just it will take maybe uh, hardly 20 to 30 minutes to install everything, right? And then it's very easy to work on that. So you will get Spider as an IDE. That is a really good IDE. I will show you the Spider, and then you may choose to use uh, Jupyter Notebook, even though you have installed Anaconda. So Spider Scientific Python Development Environment is an IDE that has similar features to the IDE of MATLAB. So if you are comfortable with MATLAB, you can do Python coding on a Spider very easy. The text editor is enriched with syntax highlighting and code analysis tool. And we can integrate ready-to-use widgets in graphic applications. That is also interesting thing to do. And then there is IPython shell, which is a powerful interactive shell resulting in greatly enhanced Python terminal. Um, Qt console, which is a hybrid between shell and the GUI, allowing us to display graphics inside the console. That was the problem earlier. And the IPython notebook, which is a web interface that allows us to mix text, executable code, graphics, and formulas in a single representative. So we will see a few of the things, and that's why I prefer Anaconda, because everything is on one package and we can do a lot of things with that easily. So easy is the keyword here. So the Jupyter notebook that I will start now in few minutes. Yeah, we can merge executable code, text, formula, image, and animation to a single web document, and it is useful for many purposes such as presentation, tutorials, debugging, and so forth. So for today's class, I will use the Jupyter notebook. So that you can go and online you search Jupyter notebook, and you will get a terminal of Jupyter notebook, and then we will start. Mostly in today's lecture, maybe I will be concentrating on three packages that helps you in data preparation, data extraction, and data visualization. Numpy, Matplotlib, and Pandas. Uh, uh, I will explain one by one. Yes. Numpy is a numerical Python abbreviated NUMPY, is a foundational library for scientific computing in Python. This is going to provide you essential data structures for high performance, performance computing, um, which basic Python is not providing you. And you will see the ease of using this NumPy package. Uh, this package provides following features, and although there are several features, but this is, I mean, key features you can say. So ND array, this is a multi-dimensional array, much faster and more efficient than basic package that you have seen in Python. And then element-wise computation you can do. There is interesting thing about broadcasting as well. And so that you may. So, and that is different than several of the programming languages you have seen. Reading, writing data sets that you can do here, and you can store it on a hard disk, and integration with other languages such as C, C++, and Fortran. That is also so, but not everything I will able to do today, but a little bit of exposure to this NumPy, and then. Pandas, this is for complex data structures and functions. You can use it. So, for example, dictionary structure, that data structure that you can see in Panda, and it's very efficient thing to work with. Uh, it's very core thing, Panda. So you need to know this Pandas because you can handle data very efficiently using this. Fundamental concept of this package is the data frame, a two-dimensional tabular structure with row and column labels. Now see, this is the same structure on which MATLAB sits. So if you can see in MATLAB, every variable is a matrix, right? So there is a tabular structure that you see in MATLAB. The same thing that you can see in Pandas. So, and the third package that we will be interested in will be Matplotlib, and this is for data visualization. Mostly in two-dimensional, it has following features: extreme simplicity in its use, gradual development, and interactive data visualization. Some of the people sitting from academic world, expressions and text in LaTeX. That's an interesting thing to note, and greater control over graphic elements. I export to many formats such as PNG, PDF, SPG, and IPS. What I can tell you that if you have seen MATLAB, you are comfortable with MATLAB. The way MATLAB figures are so good to visualize, the properties, that the ease of plotting that in MATLAB, the same thing you can see in Matplotlib. Actually, the developer of this package, uh, actually they were very much inspired from MATLAB, and they have done a wonderful job of bringing those beautiful elements of MATLAB, plotting into this Matplotlib. Okay, so this is how the introduction that I wanted to give you on today's uh, today's program. Let's begin with Python programming. Are you ready for that?
Are you ready for programming?
Yes, sir. Please
Yes,
start.
sir.
मतलब सिर्फ जो है सो अजय बाबू की ही सुनेंगे, हमारी कभी नहीं सुनेंगे, राइट? So let's start with this Jupyter notebook. How to show this? Okay. Let me show.
Hello, sir.
Yeah.
Sir, one request is that like whatever you code in the program part, so please
Hmm.
copy the code into a notepad so that we can get those files and later we can implement those codes.
Definitely, I will save it. I will send it to you. Is that okay?
Yes, sir. Yes, sir. Okay. Thank you, sir.
So actually, that you will see that you can save whatever you are doing even on iPad, Jupyter notebook. So don't worry about that. Hmm? Okay. Hmm.
Okay, sir.
So how to start with that? Let me do with this. I wanted to show you. So I have installed Anaconda on my computer, and rather than showing you uh, all the things, I will show you the Jupyter notebook and Spider notebook, both of the things. So Jupyter is no, web interface that you will be having, and Spider is an IDE that sits on in your computer, and there you can put all the Python code. You can manage a project, big Python codes you can work with. But on Jupyter Notebook, small programs, it is to learn, it is to uh, you know Uh, let me show just a minute. So whatever I will be putting on this screen will be shared. So let me do this. Yeah. Can you see this? Uh, this is Spider. This is Spider ID. Can you see this? So here you can write your codes, and this is the console that where you will see if you are putting uh, executing that code. For example, let me say start with say print, and now you can see that this is very interactive. Okay. Because IDE is going to help you in completing your code. Oh my God, what happened? So hello is the first thing that I want to do, and see. I got here the message as hello. Is this visible to you, or I need to?
Sir, please increase the size.
Well, that is what
Yeah, yes, sir, it is visible.
it is
Increase the.
visible now. Okay,
Yes, sir.
okay. Just a minute. I will do this. So, is this okay?
It is
So this
perfect.
is this is the spider ID that we can see, and here you can write all the code, and that you can execute, and it will be shown here as in console here as well. You can complete your several of the lines, and then you can execute in one way, in one go. You can do it one by one as well. So this is this is a good ID, I can tell you. A spider is a very nice ID to work with. So I will recommend this. There are other IDs as well. For example, Sublime is there a good ID. But with Anaconda, this spider is free. You can use this. That is how. Uh, so let me show this. Uh, Jupyter notebook once, and then we will go. So this is a Jupyter notebook. You can do this. If you have installed Anaconda, this is again this is available to you. But if you are not having Anaconda now, you just go into your web browser and Google it about Jupyter, this online notebook, and then just click this. You will get this the same window that you can see here, although the web address will be different. And then you go into this new. You go into new and select Python 3. This is notebook in Python 3. You will get this cell in which you can write your commands here, Python commands here, and you will get the output just below this. And for example, if I want to the same thing, the print hello, I can do now. So I can do now, and for executing, you need to run, and you will get the program executed. Now, a few things that is important to know before starting is this indentation is a very important thing in Python, because you don't need to tell Python about blocks in your code. It actually gets through how you are indenting your code. So you don't need braces. You don't need those blocks writing. Just you have to indent properly, and you will able to let Python decide about that. So let me start with Numpy. Numpy is a package that mostly is important for your numerical computation, and I will start with the small things. I mean, very simple things to start with. I will say that this array thing that is very important to start with, because that will contain your data, and Numpy gives you certain advantage in dealing with this ND array. How you can call Numpy package is just by writing this one statement of import Numpy as NP. So now we are declaring one instance of Numpy as NP. So NP is going to help us in accessing several of the functions of Numpy. Let us start. So I am going to create first array, a equal to np.array. So this is going to be an array, and I want to give initialize this array. The way you can see that np array, you have to initialize by giving a list, and list can be one dimensional or two dimensional or whatever, three dimensional, whatever it may be. So let us start with simple. This uh, simple way is just putting any random numbers here: 4, 5, 8, 9, uh, uh, 3. So this is how my I have provided this list, and I want this list uh, to be known as NP type array, so that the NumPy type array, and that should be called as A as an that array name is A. Now I want to know whether this has created in A or not. So I will just give this much. In Jupyter Notebook, you don't need to write print here for this. You just put A, and if you have some exposure to MATLAB, the same way MATLAB also gives you this flexibility on the command line. But you can print only one variable at one time. That's the problem that you will be having. For example, if you want to create another array, say maybe b equal to np dot array. Let me say 6, 7. Now I want to print both of them. Then I need to put this print. Now see, the formatting way is very simple. A equal to, if I want to get printed A equal to A, and in the same line I can think of putting on the new line B equal to B. So if we are going to execute this, what will happen, that whatever that has been stored in A and B, that will get printed as A equal to that particular thing and B equal to that particular thing. That is what it gets printed here. So here now you can see that A equal to this array of 4, 5, 8, 9, 3 elements, and B is 6, 7. So you can get what is a type of A, what actually this data structure is. So let us say just type. This is a function that you can use. So type, what is a type of A? Now see, if we are going to run this, this is the type of A is numpy.nd array. This is what the information that we are getting. Now, if we want to know that what is the type of the elements of array, which type of elements this array is having, then there is a function that you can call is a dot d type. Now, if you are going to call this this d type, data type is int 32, and that means this is an integer with 32 bits. Is that okay? So you can put several of the functions that has been loaded here with this np.array. You can think of what is the dimension of array, then what is the size, and what is shape. I mean, these three functions that gives you some idea about what type of array it is. Okay. So for example, shape will give you about whether this is two-dimensional array or one-dimensional array by giving you this the dimension of row and column. So let us see this a dot shape, that is important, and then call this a dot shape. What it is saying? This is saying that this array is having um, five elements into it, and this is one dimensional array. That is what it is saying, right? Okay. So now we have seen one dimensional array. Two dimensional array is also not so difficult to do. Uh, so so let us think about that two dimensional array. So I will use a2 equal to np dot array. Now you have to see the initialization the way I'm initializing. First one is about because I want two dimensional, so this is for the first dimension, and then and in this I will have to give two dimensional list, and that is what I will put it here. So maybe suppose 2 and 3 is one element, and then this separated by maybe 4, 6. Now if we want to print a2, so a2, let us see what is that it is giving you. So it is a two-dimensional array that we can see here. You can make array of any dimension by initializing. Sometimes you don't want to initialize, then you just give this just a shape without putting any element into that. Another way is that you can think about initializing zeros if you know the actual shape of the list or the dimension of the list. Then you can simply provide that and initialize 0 or 1s as well. So for example, maybe I'm saying a3 equal to np dot zeros, and this is the same thing that you would have seen here in MATLAB as well. Now I am putting this dimension of 2 and 3, 2 rows and 3 columns. So let us see what is that a3 will give you. So you are getting this this array with initialized as 0, and this is a floating 0. That's why 0 point that you are seeing. So let us think about this. What is a dot d type here? No, a3 dot d type. So you can see float 64 is the type of elements of a3. So you can create simply the way that you are having these zeros, you are having also ones. You can use that ones as well for creating with initialized as each element as. Now you have to be careful in giving dimension. Let me give 4, 2, and then this. So this has been initialized as each element is 1. Okay. We have created an array, two-dimensional as well as one-dimensional. You can create with strings. You can create this array with characters, um, whatever the way you want to, you can do that. Mm. So after that, we would like to see a few uh, interesting things that Python and Numpy is had. For example, you can think of populating or say generating a sequence uh, as an array. Uh, so, for example, suppose we want to uh, generate a sequence from say 1 to 9. So then what we can do? So I'm saying this sequence. Let me put this with capital A equal to. For that, there is a function that is arrange. Arrange. It is not arrange. Arrange. So now you have to be careful here that if suppose I want this sequence starting from 1, whatever that you want to start with, that should be the first argument, and whatever you think will be the last of that, last element of that. Add 1 to it. So, for example, if I want 10, I have to put here 11, and then I will say, just tell me what is that I got within A. So if you can see that this array I have created is 1, 2, 3, 4, 5 up to 10, not 11, although I have given argument as 11. That is what we should be careful about when we are using arrange. Now, it was by default it is the sequence with with the distance, or say with d as 1, but you can change that as well. For example, let me say a equal to np dot arrange, and now I want it separated by although the range is same 1 to 10, but I want this separated by say 3. So I will pass this here 3. So it will start with 1 definitely, and it will stop with less than 11, but increment will be 3. That is what I hope. Let me see whether this is going this way or not, or this is going to give me some surprise. Yeah, it has given me the same way. So 1, and then 4, then 7, and then 10. So this becomes easy, to populate, one of the sequence as an array, right? So this is now, if suppose this is the sequence that we have generated, and but we want this has come as a one list, or say one-dimensional vector. But I wanted to arrange this into two-dimensional array or as a matrix form. Then there is a function that you can use, and this is interesting function which is known as reshape. This is this same thing in MATLAB also. We see this function as Uh, so let me put capital P equal to uh, this is a dot reshape. A dot reshape. Maybe I will put the argument as 2, 2. A And let me see whether this works or not, or this will require np dot reset. No, this worked. So we got b as, that with the element 14710, it has given us, uh, a matrix. Now that is very good that we changed one dimensional list to two-dimensional matrix. Now, if suppose I want to go otherwise, so from B to A, then what can we do? So that is another function that you would see here is ravel. The unravel, that untangle, so ravel is also a word that says the same meaning with unravel. So this will untangle it. So let us say C equal to uh, B dot ravel. Let us see whether this works or not. It worked, and you can see that the same array that we were having, we got here again. So in this way you can play with the list, and that is what I intended to give you. There is one more one more function that sometimes numerical analyst, or even say somebody in academics would like to know, is about sorry. So it is about there is a method known as Lin Space, and that is very similar to arrange. But you don't need to say the distance. Rather than, you can say that how many elements that you want to uh, generate within that range. That is what advantage that you will be seeing here. So, for example, if I am using this d equal to np dot lin space, and I will give argument as say 0 to say 20, and I want to say I want to know I want to get 7 elements. 1 to 20 I have written. Sorry, let me say 0 to 20 is the range, and I want 7 elements within this range, equidistance. Then this is going to help me in getting. So let me see whether D is giving me this or not. So whether 7 elements I got, 0, then 3.33, 1, 2, 3, 4, 5, 6, 7. Yes, I got 7. And this is equidistant. So this is, there's another function that may be useful. Now, for the people who are mostly interested in statistics, you need to know this random number. And there is a function random here in this library, which is a useful function. This will give you this is almost like getting a uniform getting a random number from the uniform distribution between 0 to 1. And let us start putting that. So let us say let me put R1. This R1 is say NP. Now you have to see NP dot. There is a library which is known as random, and inside this sub library in the Numpy. So you are calling that, and in that there is a function again with the same name, random. And let us say I'm putting, I want say 5 numbers, random numbers, um, drawing from uniform distribution 0 to 1, and this is what I want to fetch. So I got this, so each time I will call this np.random, I will get a different, random number. Now I am not satisfied whether, this is coming from uniform distribution. I mean, let us check that. Okay. So rather than doing so much of the analysis about this, what I will do that I will generate lots of random number, big array. Um, so R2, and then I will see what is the range, what is the mean, what is the standard deviation, and that is what I want to show here. So let me say np dot random dot random, and then maybe I'm saying 1000 values that I'm generating. I will not print everything because then, I mean, the purpose I will lose. So what I want to print here is what is the minimum of this. So I will print minimum value. Minimum equal to R2 dot. Now there is a function known as mean. That can help us, कहाँ चला गया ये mouse? So rather than just thinking about minimum, let us do all the things. Minimum is this, then maximum equal to, again there is a function R2 dot max. Then suppose we want the mean of this. So mean equal to R2 dot mean. Suppose you want standard deviation. So simple it is standard deviation. So STD is the function, if I'm not wrong. So let us see whether the same thing it is giving us. Oh my God. What happened? Can you spot the problem? So I have spotted. So I missed one thing, and that is, if you can see here, Here one comma I missed, and that is how the syntax error can. Again, it is nowhere. Here also. Oh my God, what I am doing. एक बार में नहीं मिस, दो बार मिस किया हमने. यहाँ देख लो, यहाँ ठीक है. Okay, now it should work. So minimum, if you can see, is this almost 0. Maximum is almost, oh my God, standard deviation हमने कैसे block लिखा है? I have missed here n as well. Anyway, and that's why you are getting a standard deviation here as this oblique standard deviation. So this is how you can calculate some of the things, and next phase. This was a gentle introduction to array, two-dimensional array. You can generate. Next important thing that for doing anything with respect to data in Python is this index, how you are going to access some of the indices of those array, and also how you are going to slice, how you are going to this join. I mean those things maybe that we are going to learn. And then after that, maybe we will go to pandas. Okay, this is how. Okay, yeah. So let us start with accessing first. So if suppose how we can access the arrays, and then we will go into this slicing thing. So suppose we were having this somewhere A was there. Can you see this capital A array? Array A is कहीं कहीं हमने चेंज भी कर दिया ना ये को, तो ये काम नहीं करेगा. एक मिनट रुको. Okay, let us see this capital D. Capital D is this array, 0 point, this, and this. I want to check what is the first element of this capital D. I want to print that. So capital D, and then the first element I want. So what I should put here? The square bracket. I want to check first element. So the indexing, it starts with 0, and that is what I wanted to show you. So the first element is 0. 0 at 0 index. That is how Python works. It is different than MATLAB here, because in MATLAB you don't have 0 indexes, 1 index you start with. So this is the difference. I thought that. But there is interesting thing with Python, and that is that you can give negative indices as well. Now that I have not seen in most of the programming language. And suppose I'm saying D minus 1. What is that it is going to give me? Interestingly, it will give me the last element of this array, and you just see that it is giving you 20, because if you can see here, D was having 0, 3.33, 6.66, and 10, then 13.33, and last element was 20. So if suppose from last I want third element, from last I want third element. So So I will say -3, and it will give me 30.8. So this is what the interesting thing in Numpy was, that you can access uh, by giving indices in forward way, you can go backward as well. So okay. Now, how to access this two-dimensional array? So we were having a two-dimensional array somewhere, we reshaped it, right? Let us see. So which we reshaped in B. We reshaped, right? Yeah. Let us see B first. Okay. What is B? So B is this, and I want to access, say, this element in uh, second row, first column. How to do that? So I will do this B. So second row, that's why this is 1, and then first column, this is 0. So I am expecting that 7 will get displayed. That is what I am expecting. I may be wrong. Oh, I'm right. So it has given me this element. So now it will be very simple for you that how to access the two-dimensional array here. The important part, because we are dealing with tabular format, two-dimensional array, that mostly that we are thinking, not three-dimensional here, and that is mostly that we are going to deal with. So so the most important thing that we usually do with this manipulation is about data manipulation, is the slicing of arrays, or matrices in some way, and that is what we are going to learn. Maybe we will start in the next session. So Professor Ajay,
Yes, sir.
I have taken 1 hour 30 minutes. Whether there is a break or anything like that?
Yes, sir. Please take a break for 30 minutes, and we will meet again at 11. And
Okay.
thank you sir, for such a nice explanation. So,
And
dear participants, we will meet again at 11. So please take rest for 30 minutes. Thank you, sir.
thank you very much.